Hello, this is Dr. Hassan Abdullah with the course Complexity and Analysis of Algorithms. So, we are in the second part of the first topic, which was basics. And in this part, we'll talk about heuristics. And in the next part, C, we'll talk about brute force, which, of course, neither brute force is an algorithm nor heuristic is an algorithm. So, that's the purpose. So, this course consists of a supplemental website, which will be used for teaching, and there's a lot of useful content there and searchable. So the address is www.easymcq.com/goget. So this is the course content in front of you. As you can see, there are 11 topics, and we are at the first topic, which is the basics. And the supplemental website, which I mentioned, that is the learning management system. It consists of many useful tools and facilities and features which will facilitate you, which will help you, and which will enable you to get the most out of this course. And these are the 6 videos which will help you and teach you how to use these features. So now we move on to the supplemental website. So we are at the supplemental website, and as you can see, there are quite a few courses here, cutting edge hard courses such as natural language processing and machine learning, artificial intelligence, in addition to the core computer science courses. So we move on to the course of our interest, which is analysis of algorithms. And we are at the basics topic, and in the basics topics we have covered the questions and answers, which I'm skipping, and now I am moving to the questions and answers for this section. And so, what is a heuristic? So, a heuristic is, by definition, it is non-deterministic. If you recall, the qualities of an algorithm was that the algorithm has to be deterministic. That is, for the same input, it should generate the same output, no matter how many times the algorithm is used. So it is non-deterministic. And why we use heuristic, or which they are also called as a rule of thumb procedures, because we don't have the algorithms to get the answers, perfect answers, or we don't have the time, or we don't have the resources, or we don't have the requirement, and so on. So the characteristics of heuristic are that they are non-deterministic. It means that may produce different outputs for the same input on different runs. Non-deterministic. Then they are approximate. Approximate means that the answer or the result which is provided by the heuristic is not the exact result. There is no guarantee that it is the optimum result. Okay, does not guarantee an optimal or even feasible solution. It may not even be a feasible solution. Of course, it's a quick solution. It is a quick solution. And there are many examples of heuristics. For example, greedy algorithms, which is a full topic, and in the next Q&A, I'll go into more details with the problem itself. And then there are heuristic search algorithms, such as the A star search algorithm. And of course, they are looking for the feasible solution in the search space, but does not guarantee an optimal. There's no guarantee of optimality. So why we use exact solution is not feasible. Why it is not feasible? Because due to time constraints. Why it is not feasible? Because due to the space constraints. And there could be other constraints also. And why we use them? Because finding a quick, satisfactory solution is more important. For example, this is I'm not a stock trader, and I'm not a financial specialist. But say, for example, if I want to invest and buy some stock, and I get the best answer, or the best the result is computed for me after 1 hour, while the stock price is changing every minute, so that best result is not useful at all. It was a waste of resources and a waste of time, and that is not useful at all. Maybe if I would have gotten a result in 30 seconds, and of course that is not the optimal, and I am happy to have a certain result and outcome, then it's better than the perfect result, which is not useful. So give some examples of heuristics with respect to the problem solved. So for different problem, there are different heuristics, obviously. So greedy algorithm, finding the minimum spanning tree or solving the fractional knapsack problem. Fractional knapsack problem means that there are certain items, and part of the items can be placed in a knapsack, and every item has a certain value, and the problem is that the knapsack has a certain weight carrying capacity. So you cannot put everything in it, and everything may not be available to put into it. So that's a difficult problem. So a greedy approach can be used to solve the fractional knapsack problem, and the minimum spanning tree. So we have quite a few question and answers. You can also search them. So what is the heuristic? The heuristic is always choose the locally optimal solution. Locally optimal solution means that the solution which seems to be the best at this point in time, based upon the available solution, choose that solution. And for certain problem, it does work. but for certain problems it may not work, in the hope of finding a global optimum that is the best possible result. And of course, the history is to take the items with the highest value to weight ratio first for the fractional knapsack problem. Kruskal's algorithm, Prim's algorithm, they generate a minimum spanning tree, and the grid works there, and the grid works, but it may not work for many problems. For example, for the traveling salesperson problem, the grid does not work. Then the A star, the search algorithm, pathfinding navigation systems. A star algorithm uses a heuristic to estimate the cost from a given node to the goal node, and that is an estimate. So by definition, it's an estimate, and the goal is to reach the goal from the node as per this cost relationship. So in a grid-based map, this with Manhattan distance, like sum of absolute differences in terms of the block and the street, okay? Estimate the cost of reaching the goal. It is just an estimate, okay? It's not the perfect result. Simulated annealing following the optimization problems like traveling salesperson problem. There is an example also. So what is annealing? Annealing basically is a process of metallurgical process of strengthening the properties of a sword. And so what's special about those swords? The special is that they were flexible, so they did not break apart, and they were sharp enough to cut through a very fine fabric also, and of course cut through the armor also as simulated. That is why it's called simulated annealing. And physical power, heating and slowly cooling a material to reach its minimum energy state. So what happens in simulated annealing is that the energy is provided and the state makes big changes, okay? Or the probability that the decrease over time, and as the time progresses, the temperature is there are not big changes in the temperature. So what happens is that the solution may get out of the local optima, and it does work. So there is some example and simulation I'll show you. So it is used for traveling salesperson problem to explore other possible solutions, and in many instances it has given good results, but not the optimum result. There is no guarantee. Then is the genetic algorithms, which is again a heuristic approach, finding the best combination of resources. Basically, it is using the best genes to combine and generate better genes, and of course, there's mutation, and there's a whole problem and solution process which we'll cover, which is the last topic of this course, genetic algorithms, and the mutate and they evolve over generations. So knapsack problem, which is not the fractional knapsack problem, it has shown to produce good results. Good results, not the optimum results. Then the hill climbing is a local search algorithm that starts from an arbitrary solution and iteratively moves to the neighboring solutions that are better, okay, until a peak is used. So basically, if it can be hill climbing, you obviously the objective is to go towards the global optima, of course, but how to ensure, okay, could involve starting at a random point and then iteratively moving to the neighboring point. There's no guarantee of optimality. Nearest neighbor search, going to the nearest neighbor. For example, there is a courier service or a delivery service. It has to dispatch and deliver letters or packages, and of course it goes to the closest one, nearest neighbor, and there's no guarantee of having a route which is low cost. Best first search, graph traversal, best first search that explores the most promising node first. There can be different criteria of identifying which node is the most promising one, and choose to explore the node that appears to be the closest to the that appears to be closest to the goal, right? Appears. So like A star algorithm, it's a path finding to fall to a straight line distance to the goal. So these are some of the heuristics. Now let's move on to some historical heuristics. So this is more towards the domain of computer science problem solving. And of course, if you are interested, there are a lot of references I have made available. You can check them. So what are the rule of thumb heuristics? It's very interesting. For example, why people use rule of thumb heuristics? Now we are not saying how to implement them. The previous one were the one which are implemented, and some of them actually give optimum result also. But there's no guarantee for all the problems. So why they are used? Because they are simple. Simplicity, they provide quick approximate solutions. Approximate algorithms is a different domain which we will cover towards the end of the course without needing exhaustive information. So they don't require a lot of information. So for example, simplicity is a rule of thumb. If somebody is wearing glasses, so it is assumed that the person is smart. So usually I don't wear glasses, and you know what type of person could be teaching you. Practicality, they are based on experience and practical real world situations. So we say that we have seen this happen before and that we have experienced, so it is going to happen again. And when the time is limited, resources are limited. I'll give you some examples. They simplify complex problems by reducing the number of options. And of course, those options which are not considered, they may be very unlikely to happen and so on. But the common thing among all of them, they are not optimal. Okay. So some examples of rule of thumb: 80-20 rule, which is basically says that 20% of the people are doing the work of the 80% of the people. And in business, 80% of the revenue comes from 20% of the customers and so on. So I don't know whether there are any hard and fast proofs, because how do we know that 21% people are not doing the work of 79% of the people and so on, or the other way around also. So that's a rule of thumb. Okay. Availability of a heuristic. The heuristic is based on the idea that people judge the likelihood of an event by how easily the examples are available. For example, people say that overestimate the likelihood of an air accident, while air travel is much safer than driving. Of course, in case of an air accident, there are less likelihood of a safe exit from the site of the crash. That is true, but there are more statistics shows that there are more driving accidents as compared to air travel accidents. But that is a heuristic. Okay. Anchoring and adjustment heuristic involves starting with an initial anchor, arbitrary number, and making adjustments. For example, negotiation if the offer is really high or low, and then you see that. Then you just decide you are buying a house, and somebody is asking for a price, and you randomly decide that no, this seems to be a good offer, and then there's argument, and then you may increase your offer, and so on. So then the 5 second rule, 5 second rule says that if some food items fall on the floor, and if you pick that item and you eat it within 5 seconds, it doesn't get contaminated. Well, this is a heuristic because it depends upon the type of item, it depends upon the contamination on the floor, and how come it's 5 seconds? What's the research behind it? Why not it's 4.5 seconds, or why not it's 5.5 seconds? And then of course there are other rules also. Rule of thumb for decision making, because it just feels right. Now, feels right may not be true for an ordinary person who is not experienced in their domain, but the feels right could be possible for somebody who has spent his or her life in a certain domain. So that is again a rule of thumb. So what are the advantages and disadvantages of heuristics? So because there's a reason why people have been using heuristics for so long, and there is a reason why people don't use heuristics. Okay. So advantages is the speed. So it doesn't require a lot of working, it doesn't require a lot of calculations, it doesn't require a lot of thinking, and it doesn't require a lot of coding. Okay. So speed is reduce cognitive load. By simplifying heuristic, reduce the mental effort. So you see a person with a certain appearance, with a certain attire, and without thinking, you make a stereotypic conclusion about the background of that person, or about the habits of that person, which may be totally wrong. And it is practical also. In many real life situations that may work, and in many real life situations it may not work. So it varies from situation to situation. So the disadvantage of heuristics is that they lead to systematic errors or biasness. Over relying on heuristics. Okay. Risk assessment, faulty risk assessment. So you experience that this kind, you a black cat cross your path, and you say that now it's not a good day to go out, or something like this. So there's suboptimal solutions. There is no guarantee that the solutions are optimal, and they may not always lead to the best solution. They could have led to best solutions prior. And misapplication, using a heuristic where it's not applicable, can result in bad results. Okay. So what are the key differences between a heuristic and an algorithm? So there are a few of them. First of all is the precision. So if you would like to read more about them, there's a lot of interesting material available. So differences between an algorithm and a heuristic is the precision. Algorithms offer a precise, reliable solution. There is no precision. There is approximation with a heuristic. Algorithms are consistent and repeatable outcomes. So if a black cat crossed your path and you had bad luck, and I'm sure that if 100 times the black cat crosses your path, 100 times would not be bad luck. Okay, maybe you have a black cat as a pet cat, which always crosses your path. Consistency, consistent and repeatable outcomes. With algorithms, you perform sorting, and it will always give you the same result. And if it's bubble sort, it is stable. It will always be stable. And heuristics may result different, yield different results, different outcomes. So how can you depend upon them? Efficiency algorithm may be computationally expensive. They may require more space, and but heuristics are fast, they are quick, and they give bad results also. Algorithms suitable for problems where accuracy is paramount, and heuristics for problems where when the exact solutions are impractical. So real life is not perfect, algorithms are perfect. So maybe for certain real life problems, you are better off having heuristics, but that is not a scientific approach. And with this, we conclude this sub topic.